My name's Alex Creely. I'm almost a fourth year PhD student here at the Plasma Science and Fusion Center, and I like to say I build fancy thermometers. I'm originally from St. Louis, Missouri. I grew up there pretty much my whole life until undergrad. I had Legos when I was a little kid. I liked building stuff there. I liked putting things together. I liked figuring out how things work. I went to Princeton University for undergrad. I was a mechanical engineer there. I kind of already knew I wanted to do alternative energy of some type. I thought that energy is one of the big challenges of the world right now, and it's something we really need to work on. I heard about fusion, and the more I learned about it, the more I thought, wow, this is an awesome thing to study. It could really make a big change if we get it to work. Here at MIT, I study generically plasma fusion. More specifically, I study turbulence. Basically, I build hardware, so diagnostic machinery, that measures the temperature of the plasma inside of our fusion device. And then specifically measures little fluctuations in that temperature. And we can use these measurements to learn about turbulence in the plasma, learn about how that transfers heat out of the plasma, because we want to keep the heat in the plasma as long as we can to do fusion. And then we can also take that information and compare to simulation. Plasma turbulence is one of the main things that drives heat out of the plasma. So in order to get fusion to work, you have to keep your energy in the plasma for as long as possible. But turbulence pushes all of the heat out. It slowly, the heat leaks out of the plasma. And because of that, we need to understand it better in order to get a fusion machine to work. One pathway forward is to use a simulation code to design your next machine. So there's these code called gyrokinetic codes. Basically, what they do is simulate turbulence in the plasma. So part of the work I'm doing is making more precise experimental measurements, making different experimental measurements, with the ultimate goal of figuring out how to improve these gyrokinetic codes, how to make them better, how to make them more accurate, but also get a sense of when they're right and when they're wrong, so that when we use these codes to predict a future machine, we'll have a better sense of how confident we are in these predictions. I really enjoy fusion energy research. It's both very intellectually interesting. There's a lot of problem solving you have to do, a lot of interesting physics, a lot of interesting engineering, but also I think it's something really meaningful to work on. It's something that I would love to put time and energy into, because I think that if we're successful, it can really make a change in the world by producing clean, safe, bountiful energy.